It automatically turns everyone's camera on when I start recording. No, I'm just kidding. Okay. So let's take a look at the June 2014 exam. I'm going to skip around quite a bit. We might do like kind of sections of multiple choice. I like to do that, so we're not just too focused on like one particular question. Let's start with, I think this is a good starting point. So we'll literally start off with 1, 2, 3 for multiple choice. I'll give you guys a few minutes. We'll take a look at them together. And let's get cooking here. So again, this is the June 2014. I did post a link of what the PDF looks like of the PDF on Classroom if you want to have it there. If you want to just look here. Again, we're not going to do every question, but we'll skip around a little bit. If you want to, maybe a good idea if you have your notebook or scrap paper, I'll do like this. We'll do some that we just start together and some where I'll give you a few minutes. These are pretty easy to start, so I'll give you around 60, 90 seconds. How many people got? 60. Which class has the most people here? What's the best class? All right, and number one, going over the property. Well, I don't know when you first start doing these, elementary school, maybe late elementary school, the basic properties. So we don't have to worry about actually solving that equation. They just want to know what happened that allowed you to do this. So let's just gauge what happened from the first line to the second line. What actually happened? The -9 is gone because we've added 9 to both sides. So what did we think for number one? Which property justifies that? Yeah, choice one, the addition property of equality. We're a little bit more used to, I would say, like choice two, the commutative or associative. But when we actually move things around, those have a name. Like what allows us to add the same number to both sides? The addition property of equality. There's blank property of equality for all of them: subtraction, multiplication, division. Commutative would be you switching the order on the same side. Associative would be grouping. All right, for number two, officials in a small town use a function C to analyze traffic patterns. C of n represents the rate of traffic. What would be the most appropriate domain? Okay, so domain tells us we're looking at the inputs here. So if they're saying n represents, hey, like they're counting cars basically. What would be an appropriate domain if we're counting cars? What would be an appropriate domain if we were counting cars? Choice 4. Obviously, we can't count a negative, and we can't count fractional amounts. What would be the technical term for 0, 1, 2, 3? What's another name we can give this if they didn't actually give us a list? There's two things you could say. All positive isn't really specific enough. You could say whole numbers. You could say non-negative integers, which is kind of like a little bit of you're combining two different things, because integers include negatives. So if you say non-negative integers, you can kind of counteract that. But whole numbers work. Yeah, positive integers, I guess, works too. Okay, and let's look at 3 together. This is kind of like, this came up a little bit in the Do Now today, this idea of like polynomial stuff. What do you want to be careful of with a problem like this? This is like a good example of an easier question that we don't want to make a silly mistake. Oops. What do you want to be careful of with a problem like this? Good, Studi, Kira, and Rachel. The idea that if I just write it like this, I'm going to get this wrong. So all I did was literally, I substituted an A, I substituted an B. Like, how could I be making a mistake? What am I forgetting? If I don't put the parentheses there, I'm not really subtracting B. I'm just subtracting the first term. So the parentheses, even though they don't exist, have to go there. And now we distribute the negative. So that becomes plus 2x squared plus 6x and then minus 7. Now I combine like terms. I get 5x squared. 5 and 6x gives me 11x. And it was negative 6. I'm a little sloppy here. Negative 6 and negative 7 gives me minus 13. So putting that all together, that should be choice 2. Yeah, I made them look like brackets, but those should be like normal parentheses. Okay, questions with 1, 2, or 3. Not that it always follows this pattern, but usually I would say like the test does progress a little bit like easier to harder, somewhat for multiple choice. That doesn't mean that 1 will be the easiest and 24 will be the hardest. That it's not literal, but usually, especially early on, they're usually on the easier side. Okay, they give you like a little bit of a confidence boost. Number 5 would have fit what we did today. I could have thrown that in this lesson. I'm trying to skip around. Okay. I'm trying to gauge myself on time. Okay. Let's look at this table together. And then we'll look, I want to do 7 and 8, but let's look at the table together. So we have a table. I'll let you read it, the year versus the balance. And the question is, what type of model represents this data? What do we think for this? I'll give you a second. What do we think for this? Is it linear? Is it exponential? Studi says definitely not linear. Exponential. Anthony says 4. Cooper says expo markers. 4. Okay, so what would this difference between linear and exponential, if something was linear, what would have to be the case about it? Linear would have to have a constant rate of change. So there's no tricks with the year. Sometimes they skip, right? But it's going up 10. So I could just eyeball this. This looks like, let's just call it, it's going up around 200. And then look later on, it's going up like almost 1,000. So it's pretty clear that this is not going up the same amount, just like with a quick eyeball. So it's either going to be choice 3 or 4. And even this we can eyeball. What's the difference between growth and decay? Very simple. Maybe not. Yeah, it's going up. It's increasing. Increasing or basically growth and decay is like increase or decrease. So is this going up or going down? Going up. Okay. Exponential growth function. Questions with that one? All right. And let's try these two. I do want to leave some time for written, obviously, so I might skip a decent chunk of multiple choice here or there, but kind of picking some that I like. The other thing with Regents exams, where I used to be at the point where, like, you know, my first few years here, there was like, we didn't have enough. We almost had to like make up like practice Regents because was like only a handful. Now we're at the point where I don't even know the number. If someone were to count on the topic sheet, probably like close to 20 exams, I want to say, right? So like from now, even if we did one exam a day, we wouldn't be able to finish. And doing a one exam a day isn't very realistic. So let's say we don't get to do the August 2016. I'm just picking a random one. I do have all the Regents done myself, like PDFs, like my normal lessons or like review sheets. So anything that we don't finish, if you're like, hey, I wanted to work on this with mom or dad or someone or my tutor, I'll eventually get to the point where we upload all the Regents and all the solutions. Okay, another minute. Look at 7 and 8. 7 and 8 in a minute. What if they happen to use? Yeah, I don't think they will do that, Anthony. I was talking to Mr. Manello about that. If I had to guess, I would say that they're probably going to use the one they were going to use last year and like do this. Not literally, but type of thing. Because they had to have an exam ready to go last year. It's not like they make it up like the week before. Yeah, the Regents company is like Questar. It used to be. Okay, for number 7, basically just asking us, what does the 5.25 represent? So this is like, if you want to give this a title, modeling functions. What did we say for number 7? We're given this linear equation. What is 5? Or almost like the very last question on your stat test. Like, hey, what did that number mean? People are saying 3 in the chat. Everyone's saying 3. Yeah, 5.25 we clearly know is like the rate, right? So we're looking for something, the keywords are like something with each or per, and it makes sense how much it costs for each radio. What would 125 be? I know it didn't ask this, but what would you say 125 is in this scenario? Which choice would fit 125? The startup cost, yeah. Y-intercept is always this idea of like some initial starting, something that just happened once. And the slope, we're looking for some connection to a rate of change, something that's happening over and over again per this every month, how much it costs for every radio. All right, for number 8, we have x squared minus 6x minus 12, and it wants to know which equation has the same solution. So these are kind of annoying in the sense that, and also kind of nice, we don't actually have to solve this. It just wants to know, hey, like do something to this equation and make it look like one of these things. So what happened in number 8 pretty clearly was that someone completed the square, it's called. Okay? They created a bubble squared. This is not factorable as is. Okay? We can't factor this as a perfect trinomial right now. So we can complete the square and get it to look like one of these choices. It's obviously going to involve a 3 in some capacity. Can anyone tell me cleverly here how we can cross off two choices right away? How can we cross off 2 choices right away? Very good. Yeah. And this is what I mean. Like little strategies like this are things that are important, like don't seem that important, but they could definitely help. Now, why did we do that? How do we know that? We haven't even started. Yeah. I told you guys when you use CTS, it's always going to be half of B. So we're looking for -3. So if I see +3 and +3, those are gone right away. And maybe in some cases that could even like tell you the answer. That's like a poor question on their point, on their point, because they're testing if you know how to do CTS and you didn't even need to know how to do CTS. What would the magic number be in this case? I call it the magic number that we add to both sides. 9. So technically right now I also know what the answer is, but let's pretend that we don't. Now the bubble again is going to be half of B. So if it's -6, it's going to be -3 squared. Choice 2. And I said we knew the answer because we knew the 21 on the other side. And kind of creative, I see what they were getting at. How could you get choice 4? I always like to look at the wrong answers to see like what were they trying to trick people with? If you subtracted 9. Sometimes with CTS, people do this thing where they're like +9, -9 on different sides. Now, obviously, if you think about it, that makes 0 sense, but you can kind of see how someone could do that. Or someone does this. This is how else people would do that. They type this into their calculator. They forget, hey, when I square something, it should be positive, and they mess that up. So don't do that. All right, let's skip around. Skip. Ooh, this is a good one from our test last week. What do you think the correlation coefficient of this would be? We'll do this quick. What do you think the correlation of this should be? Let's say this is the line of best fit. Choice 3. Yeah, so it is going down. But I know it's going to be negative. Well, how come it's not -1? What would -1 have to look like? -1 would literally be a perfect line going down. Even like -0.3, like that doesn't look this strong, but it's the only other choice that makes sense. It's negative, it's kind of good, I guess, but -1 would literally be a perfect line. Okay. How are we doing on time? Time check. A little under halfway. Okay, 21 I want to do. Sorry, I'm just trying to figure out which ones. We've done this. Some of these, like, we're going to do questions like, oh, I didn't know that one. We've done that. Let's do 21 and 23 we'll do as well. Okay, so for 21, I'll let you guys read it. These are kind of common. We've seen this trend, this like Roman numeral question. So I'll give you a minute, catch my breath. Number 21, read it and weep. So these can be kind of annoying because there's no way to answer it right away because you have to kind of look through the choices. Like you can't read this and be like, oh, it's 2, right? Like you have to check each case, if you will. So we're told a sunflower is 3 inches tall at week 0 and grows 2 inches per week. Which function, or functions plural, shown below can be used to determine the height in n weeks? All right, what do we say for this one? Does anyone want to type their answer in the chat? Let's see. Got some 4s. Let's see any variation here. Okay, so let's see. Starting with 3 inches tall, so already in my head, I'm making that connection to like, all right, this is the y-intercept, this is the starting value, and then 2 inches per week. Each week keyword tells me this is a rate, so I'm thinking of this as slope. So choice 1 is literally like the linear model there. Like 3 is what the starting amount, and 2 is the slope. What's wrong with choice 2 is that there's a lot of things wrong with choice 2. We got like variables connected here. If you do clean this up, if you're not sure, it's like 5n minus 3. And you can plug in a sample value of n, like plug in a 0 and you get -3, which doesn't make any sense. And choice 3, this is, I know it's a little weird because we're talking about functions, but does anyone know what choice 3 is kind of connecting to and from another topic? We usually don't see this, not consecutive. Yeah, very good, Rachel and Kira. Recursive. This is like a recursive rule. Recursive rules for sequences is based on the previous one. So what this is saying is like, hey, in some given week, it's the previous week plus 2, which makes sense. Hey, 2 inches every week. And then it also identifies the starting amount. So it's saying, hey, starting with 3 inches, every week it will progress 2 more, plus 2. So 3 is a good recursive rule. Usually we think in terms of sequences, but we can do it with functions as well. Very good. So 1 and 3 there. And then I said 23. For 23, this is going to be a topic we cover, I believe, in one of our upcoming days. We could have kind of squeezed it in today, but I separated it. This was called literal equations. Studi, going back to the last one, f of 0 meant like the first week. It's kind of like with sequences when we say like A1 or something, kind of similar to that. Is it recursive and arithmetic? Yeah. Well, you have arithmetic sequences, and then you have geometric, and the 2 types of rules are explicit and recursive. So not totally, to answer your question, yeah. Not totally, but you're kind of on the right track there. Yeah, exactly. Okay, so rearranging formulas was this idea of like taking an equation and solving for another variable. So in this case, they wanted us to take the volume formula. They tell us what it is, and they're saying basically solve for R. So I'm going to go ahead and rewrite this. This is not a popular topic. Most people get a little confused with this, but once you get the hang of it, it is pretty simple. It's basically just like solving a normal equation, but you don't even have to worry about numbers because you're just moving variables. So like we don't even need a calculator for this. I like to get rid of the fraction first. So how could I get rid of the 1/3? How can I get rid of the 1/3? Times 3. So let's get rid of that. That becomes 3v. And now in one move, I'm going to get rid of pi and h. You could split this up, but they're both being multiplied. I might combine it. I might as well combine the two. So I'm going to divide by pi h. And this is where it gets a little weird the first few times you do these problems because you're like, wait, what? But you just leave it like that. 3v divided by pi h is just 3v divided by pi h. And that's now equal to r squared. And what's the last step here? Square root. Square root will undo the square. So we're looking for the square root of 3v over pi h. Choice 1. Choice 3 looks close, but that would be like, for some reason, the 3 escapes, which wouldn't happen here. It's not like a perfect square or something. Okay, rearranging formulas, literal equations. We'll cover this topic if this was something you're super confused about. But once we did these, I feel like we got the hang of them early in the year. All right, so that's the multiple choice. And again, I skipped around a little bit, but I did want to leave some time for some written. This is always tough. Okay, so written starts with, we have 8 part 2 questions they're called. Now the part 2 questions, an easy way to remember them are they're worth 2 points each. So these are usually on the more briefer side because in the following section we have 4 pointers. Those usually have multiple parts. These might be just doing something quick, nothing too crazy. And they're worth the same amount as a multiple choice. There are 8 of them, so they're quite a bunch, a few here. You have a basic graph, like we're not going to do this one, but like a square root graph where you just like would make the table and plot the points. Let's do this one together. This one is a little weird. I like this one. We'll do 27. So for 27, we were given this kind of weird looking inequality, and it said determine the largest integer value of a when x equals -1. And you almost like don't know what to do first here because you're like, how am I going to solve this? There's like different letters going on. So what do you think the first thing we should do is? What should we do first for this one? We're on 27, and again, if you came a little late, June 2014. We're going to plug in the x value that they told us. So wherever I see an x, I'm going to carefully replace it with a -1. I'm just going to, I'm going to put the -1 in front of the a so it doesn't say like a times -1, but it's the same thing. All right, so all I did was replace those 2 spots where there was an x with a -1. Now let's clean this up and start actually solving this. I'm going to combine my like terms. A -2 and a -7 will give me -9. Okay, now what? Move to 9, be more specific. Good, add 9 to both sides, we get -3. Are we done? Looks like a is by itself. No, divide by -1. Yeah, we got to get rid of the negative sign. -3 divided by -1. Good. Christian, there's a random 8th grader in here, says, flip the sign. Why are we flipping the sign? Why are we flipping the sign? Yeah, we're dividing by a negative. So instead of greater than, this becomes less than. All right. And guess what? If I circle this, I move on. All right, I show my work. It's 2 points. Like, who cares? I get a 1 out of 2. I get a 1 out of 2. How come? What did we mess up here? The question actually says, what's the largest integer, right? So if my solution is a is less than 3, what's the largest integer that satisfies this? Be careful, 3 is not less than 3. 2. Don't say 2 point. I've seen people answer this question with like 2.999, 2.9, right? Those are obviously not integers. So we have to round down all the way to 2. If it was equal to, we could say 3, but obviously 3 is not less than 3 as is. So the answer to this question, it's a little weird, is 2. The answer to this 2-point question is 2. If you forget to flip the sign, 1 point. It's not like if you make a mistake, oh, I got it wrong, I'm going to get a 0. If you forgot to flip the sign, that's a -1. That's like 1 out of 2. If you forgot to write 2, -1. You had all your work. Okay? Good example of I wouldn't call that like a super trick, but I mean, look at this. Come on. If we get this wrong, like it says graph this. So just as a reminder, when we graph lines, I would write like, do you lose points if you don't show this? No, but I would still do it. It's going to help you. Like when we say to do things during a test, like it's not that it's required, but hey, you should do it just to kind of refresh yourself, if anything. So a little throwback to graphing lines. Where's the first point we're going to do? You could also use your calculator and make a table, worst case. You begin at 3. Yes, you use a calculator on the Regents. Scary that we're asking that in June. We begin at 3 on the y-axis. And how are we going to move? How are we going to move? We're going to go down 3 over 4. Technically speaking, 2 points is all you need. You will get a straight edge on the Regents, on the ruler. You will get a straight edge on the Regents. Those little like plastic clear ones that are like half a ruler. Did the line tool on that? There we go. You obviously don't have that feature, but you would just draw a line, arrows. Forget arrows, -1. That's it. And there was a follow-up here, so that was only 1 point actually. Is the point 3, 2 solution, and then it says explain based on the graph you drew. So let's plot it, not that you have to do this. Is 3, 2 a solution to the equation above? What do you think? No, still didn't get credit. We'll just verbally explain it. What do we think? I'm aware it's no, but what do we think for the explanation? Yeah. For something to be a solution to the equation, it's gotta be on the line, or the line has to pass through it. It's the same thing, right? So because this point is not on the line, we can conclude it's not a solution. So that could be our explanation. Like for something to be a solution has to be on the line, or the line has to pass through it, and this is not on the line, so it's not a solution. Doesn't touch the line, it's not on the line, whatever, however you phrase it. Yeah, do tomorrow. Okay, 2 pointers are not bad here, right? Decent 2 pointers. Ooh, this should look familiar. We'll do this very quickly. This was like almost, was this our exact, the last question on the, no, it's slightly different. The homework last night. So this is a quartic. Someone asked, will they give quartics on the Regents yesterday? Right, here's a good example. They're not super common, but this happened. And I remember when this exam was given, like this wasn't super common. Most people just do, and like teachers just do the trinomials like this. So when all of a sudden they showed like x to the 4th, people panic, they don't know what to do. So how do we handle quartics when we double bubble? Instead of starting each bubble with an x, we're going to do what? X squared. And like I said, this is very similar. And now we would do our sum product. We're looking for 2 terms that have a sum of 6 and a product of -7. So that would be 7 and -1. And right now, I got a 1 out of 2. It was very similar, John, slightly different. I think the homework was -7 and -1. Yeah, there's dots possible. Whenever they say factor completely, be suspicious that you're probably going to factor more than once. Dots is difference of 2 squares, so x plus 1, x minus 1. and we can't factor it any further. Dots. Yeah, this was almost like the exact one on the homework. I think that's why I made that. Okay. All right. This question you guys might remember. We did this in our box plot lesson. This was a 2-pointer? Wow. I thought that was a 4-pointer. Okay. So now we'll take a look at some 4-point questions. There's 4 of these. So there's 4 by 4. There's 4 4-point questions. So these are a little bit tougher, a little bit more involved. It says, write an equation that defines m of x as a trinomial. So in other words, what they're saying to do in the beginning, like clean that up and put it in standard form. Like right now, it's obviously not cleaned up. And then it says solve for x when it equals 0. Technically, it doesn't say algebraically, so we could use calculators here, but we'll do it algebraically either way. All right, so we're going to clean this up first. And again, this is a 4-pointer. Let's keep that in the back of our mind. So we're going to box method in the beginning. We would draw a 2 by 2 box. We're going to get negative 3x squared plus 10x minus 3. And don't forget, if you just leave that trinomial by itself, we still have these terms tacked on the end. So we want to add 4x squared to that and add 19. I'm going to arrange them like underneath. So that will give us x squared plus 10x plus 16. Okay, so let's write that like a little formal over here. So again, it asked us, kind of sounded harder than what it actually was. It said write it as a trinomial. And we just did that. Let's take a look at our answer for the first part. We cleaned it up, and our answer is a trinomial. It's 3 terms. All right, now we're going to solve for where this equals 0. So the first step, actually set it equal to 0. Now we just did, not too long ago, a whole unit on quadratics. What would be a good, we talked about different methods for solving them. What would be a good method to solve this one? Yeah, this factors. You could do CTS. CTS wouldn't be bad here. I was waiting for someone to say quad formula. You could do quad formula. But obviously, if something is factorable, factoring is going to be your best approach. It's going to be the fastest. Calculator we can add to this list because what is it not saying? It doesn't say algebraically. So I could write down, and just to be safe, I might put like, oh, I use my calculator table and I found the 2 answers. Yeah, Brandon, what was? Okay, so for our sum product, we're looking for a sum of 10 and a product of 16. What 2 numbers accomplish that? Here it says 8 and 2. So we're going to say x plus 8. Those are really ugly 8. And x plus 2 equals 0. I do my t-chart. I get x equals. And now for this part, we solve, I call these mini equations. We solve these mini equations. Where does x plus 8 equal 0? You could usually do this in your head. So our 2 solutions are negative 8 and negative 2. You could just leave it like that. You could write it in coordinates, I suppose. Negative 8, 0, negative 2, 0. You could write it like in those, like this, brackets that I can't make. So there's a few ways. I would, to be honest, just circle it in the t-chart. Questions on this one? I'll zoom out. This was a 4-pointer, pretty easy 4-pointer. This wasn't super complicated. Delete 724. Okay. All right, let's take a look at another 4-pointer. We're not going to do question 37 if you're like, oh, like, are we going to end with this last one? You could probably see why. I'll zoom in. I told you this when we did this question. You had this exact question in this lesson and even on your test for quadratics. This was the one that had the trick with like hundredths, if you remember. So this was 37 on that year. It was a 6-pointer. We'll do plenty of 37s across the board, but all right. So let's see 35. . Let's do this because I know I'm talking a lot and doing a lot of problems on the fly. I'll give you a minute or two to get a head start on this, maybe not even finish, but I'll let you kind of at least start this one if you want to kind of test yourself a little bit. Well, Netflix is like 15 bucks a month now. What number was the last question? Lucas, that was 33. The one before this was 33. I'm kind of skipping around a little bit. Again, take a few minutes. Yeah, Netflix used to, I think I paid $5 when I first signed up. I had Netflix when they used to, there wasn't an online, like, there wasn't like you turn on your TV and stuff. It was, they would send DVDs to your house. So you would pick out, you're like, oh, I want to watch this movie. And they would mail you the DVD and then you had to return it in the mail. They still do that. I think some people still do that. It was like 2007, 2008. Yeah, you can still do that if you want. You weren't born in 2017? This is the June 2014. The June 2014. This was the oldest one, so I figured we start with this one. All right. So I'll tell you something here. We talked about this a lot with test stuff, like little finicky type stuff. If they tell you something to call it, like they're saying here, hey, write your equation, just make sure you call it A of n. And then I start doing this, and I'm like, all right, this is my equation. Even if it's right, you're going to lose points. Like they announced, hey, use these variables. They don't, just pay extra attention to that. So I want to make sure I call this A of n. What was the equation we wrote here? So her card had 175 bucks on it. Every time she rents a movie, it becomes like 172, 25, 169.50, 166.75. So what should the original equation be that models how much money is left on this card? Netflix started in 2014? No, it didn't. John says 175 minus 2.75 n. Very good. And you could write it the other way around. You could say negative 2.75 plus 175. So 175 here is our y-intercept. That's the starting amount. No, it doesn't matter if it's capital. That doesn't matter. 175 is our starting amount. And why is, first of all, where do we get 275 from? And why is it negative? Where do we get 275 from? I don't see it anywhere in the problem. Yeah, you have to, it's not asking a lot, but you have to figure out how much these movies are. So just do the subtraction. Like, all right, I could tell a movie is 275. And it's negative because this is taking away. If we just write 275, that would imply that every time this person rents a movie, they gain $2.75, which obviously doesn't make sense. Okay. Caitlin rents a movie every Friday night. How many weeks in a row can she afford to rent a movie? Explain how you arrived. We technically could just write the answer and explain it, but might as well kind of do the solving here. What do you think? How can we figure this out algebraically? How can we figure out how many weeks in a row she can rent? It's a little repetitive to be like, all right, 1 week she has this much, 2 weeks she has this much, 3 weeks she has this much. How can we kind of set this up strategically? Calc, Grace says. Very specific. Yeah, set it equal to 0. She can keep using her gift card until it has no money on it. So let's figure out when that happens. When will she have no money on it? I'm going to add the 275 to both sides to make that like kind of separating the two here. We could have subtracted 175 as well. And now I'm going to divide 175 by 2.75. And can someone with a calculator tell me, what is that? So 175 divided by 2.75. What do we get? Anyone? Rachel says 63.63. Repeating? All right, so let's see what do they want answer-wise. How many weeks in a row? So obviously I don't want to leave my answer like that. How should we answer this? I don't want to say 63.63 if you're answering that, John. Yeah, I have to. This is one of those cases where mathematically it rounds up to 64. So why are we not? Because in the context, she wouldn't be able to afford the 64th week. She can only afford 63 straight weeks. She's going to have some money left behind on her card, but she can only afford 63. She can't afford that next week. Ethan, what's up, bud?
So I have a question. Since it didn't say to solve it algebraically, does that mean that if I did it through my calculator, how would I explain like how I arrived?
You could just explain what you did. So like you did the tables or something. Yeah, so you could just be like, hey, I used my calculator table and I checked to see where it was positive or zero, whatever like your explanation was. So yeah, he has a good point. This didn't say algebraically, so we can really say anything we want. You could even be like, oh, I got 63 weeks because I sat there and I kept subtracting 275 for an hour. Not saying that would take you an hour, but they're not giving us any explicit way of doing this. Okay. All right. So we'll put a pin in this there, I think. That was 45 minutes. Wow, this really flies by. So this was part of the June 2014. We covered a good amount of everything. Some multiple choice, some part twos, some part threes. And again, the part four in this one, we couldn't do just because we've done this. We did it in the lesson and we did it on your test, this like weird graphing question. So this is how the rest of these will kind of fit. Maybe 1 week I'll say, hey guys, we're gonna try to finish the multiple choice. For this one, I figured a good starting point would be a comprehensive overview of the whole test. Our next session, if you want to make a note, because I know he sent the schedule out, but we don't always look, is next Monday. They don't do any of them on Friday, and obviously tomorrow we're off. So Monday, that is 6/7, same time, 3:15. I'll let you know the day of like what Regents we're going to do or look at if you want to get a head start. And the code is the same one you used today. All right, guys. Any other questions? I could hang around for a minute if you had something if something was too fast or anything like that. But otherwise, have a great day. And thanks for joining. I'll see you guys on Friday. Bye, guys. Any questions? You can stick around for a minute. Yeah, there's no school tomorrow. No school tomorrow, Joyce. Go back to the last slide we did. Sure. What are you talking about? No worries. All right, guys. Have a good day.
I am the final. I'm alone. Oh, this is being recorded still.